Hey everyone! In this video, we're going to be taking a look at how we can use the properties of logarithms to help us find the derivative of some equations. So remember, there are some basic properties related to logarithms that we can use to expand or condense equations. So let's just take a look at those to remind ourselves. So we have a couple different ones. The first one, we have the logarithm of a product. So if inside my logarithm, I have a couple things that are multiplied together, remember that we can separate this, we can expand it into the log base a of u plus the log base a of v. So it's multiplication inside the logarithm, we can separate that out into addition. We have a similar one for a quotient. So if I have the log base a of u divided by v, we can separate that into the log base a of u, and now this is going to be minus the log base a of v. And then the last one is a power rule for logarithms. So if I have a logarithm, and then inside my logarithm I have something raised to a power, I can bring that power down out front. So this is going to be equivalent to r times the log base a of u. Now these properties are going to come in handy when we want to find the derivative of more complicated logarithmic functions. So why don't we take a look at a couple examples and we'll talk through the process on how to do that. So the first example here, I have y is equal to the natural log, and then inside that natural log there's a bunch of stuff. 2x minus 1 cubed, the square root of 2x to the fourth plus 1, and all of that is divided by x. Now, if I was going to try and take the derivative of this, straightforward, there'd be a combination of a lot of things. I would need the chain rule, the power rule, and a lot. But we can make this easier to work with by using our properties of logarithms. So the first thing we want to do is we actually want to expand this. So using our properties of logarithms, we can expand this out and make it more manageable. So everywhere there's a multiplication, we're going to turn that into addition, and then we have one piece of division here, we have a quotient, so then we'll subtract that. So what we're going to end up with is we have the natural log of 2x minus 1 cubed plus, since it's multiplication here, the natural log of our square root, that's 2x to the fourth plus 1. And then we're dividing by x, so then we have minus the natural log of x. Okay, we can go even further by using our power rule. So this exponent of 3, we can bring that down out front. So now we have 3 times the natural log of 2x minus 1. In my middle term, remember that the square root, that's the same as the 1/2 power. So I can turn that into 1/2 times the natural log of 2x to the fourth minus 1, and then we still have our minus natural log of x. Okay, this is fully expanded. Taking a look here, I still have the natural log of 2x minus 1. Well, because I have subtraction in here, I actually can't separate that any further. 2x minus 1 is a quantity, that all has to stay together, so we can't use our properties to separate that. The properties of logarithms only works when it's multiplication or division. But now that we are expanded, we can use our normal derivative rules to help us find our derivative. So we'll do y prime is equal to, okay, so our first term, we still have the 3 out front. And now the natural log of 2x minus 1, I am going to need to use the chain rule. So the first step, the derivative of the natural log, remember that's just 1 over whatever's on the inside of the parentheses. So it's going to be 1 over 2x minus 1. And then we need to multiply by the derivative of the inside. So the derivative of 2x, that is just 2. And we'll simplify that at the end. Plus, we're going to do the same thing for our middle term. So the derivative of the natural log, that's 1 over whatever's on the inside. So that's 2x to the fourth minus 1. And then multiplying by the derivative of the inside, using our power rule on 2x to the fourth, the 4 will come down, and that's going to turn into 8x x, and then subtracting 1 from the exponent, we get 8x cubed. And the derivative of -1 is just 0. Then our last term, the derivative of the natural log of x, that is simply 1 over x. All right, now let's simplify our equation a little bit here. So y prime, 3 times 2, that's going to give me 6 over 2x minus 1. In our middle term, I have a 1/2, and then I have an 8, so I'm going to simplify that. So in the numerator, I'm going to be left with 4x cubed. And then in the denominator, we have our 2x to the 4th minus 1. And then our last term here, we have 1 over x. So there we go. If we wanted to, we could maybe go a little bit further. We could combine these fractions together. However, our denominators are a little complicated, so I think this looks good for our derivative. So using the properties of logarithms, we're able to expand this equation and then make it easier to find the derivative. Let's go through that process one more time with another example. So the second example, I have y is equal to the natural log of 2x squared times the sine of x divided by e to the x power. So again, if I were to try to find the derivative straightforward from this initial step, it may be very complicated. But I can use the properties of logs to expand this. So let's do that and let's see what we end up with. So everywhere there's multiplication, I can separate that out. So I'm going to end up with the natural log of 2 plus the natural log of x squared plus the natural log of the sine of x. And then with our division, we have minus the natural log of e to the x power. Okay, we can go one step further in one of these terms. So we have the natural log of 2. And in the second term, I'm going to take this exponent, and I'm going to bring that down out front using our power rule. So 2 times the natural log of x, and then I'll rewrite the rest of this. And actually, in this last term, we might as well simplify this right away. So the natural log is base e, and on the inside, I have an exponential with base e. Those basically cancel each other out, and all I'm going to be left with is x. So now let's go through and find the derivative of each of these terms. So y prime. The first one, the natural log of 2, this is just a constant. I would be able to type that in my calculator and I would just get some number. Well, the natural log of 2, since that is a constant, the derivative of that is 0. My second term, I have the 2 times the natural log of x. The derivative of the natural log of x is 1 over x. In my next term, I have the natural log of the sine of x, and here we are going to need to use the chain rule. So the derivative of the natural log, we get 1 over whatever is inside those parentheses, and then multiplying this by the derivative of the inside, so the derivative of sine is cosine. And then our last term, if I take the derivative of x, we just end up with 1. So now let's clean this up a little bit. So we don't need to rewrite the 0. Our second term, we have 2 over x. Our middle term here, we have cosine divided by sine. I'm going to rewrite that as the cotangent of x. And we have minus 1. So here is our derivative. So again, we are able to use the properties of logarithms to expand these equations and make it easier to find the derivative.